Welcome back everyone to another Unreal Engine 4 tutorial, and today's video was requested by my Patreons. And let me show you what we have here. We have a maze with 3 keys that needs to meet 3 locations at the top over here, and once we do, these doors will open. So let's walk up to this, press E, let's move this up, and let's get it in its location. So key 1, let's go to the next key. I believe this was the route. There we go. Move this in. Let's select the last key. Move out. There we go. There we go. There we go. And you can see the doors are getting opened. This system is not entirely perfect because if we change it in a weird rotation, so basically if we put it like so, it's not gonna work the way we want it to. We're gonna have quite a few issues with it, because the physics handle that we are using in this tutorial basically sets the world location for a specific component, and we cannot lock that position inside of the physics handle. We can only lock it for the actual component that is getting moved, and we can only lock some of the axes. And if it's sideways like this, and if we want to move this around, it is going to change multiple axes, but we want to keep only 2 and block only 1. But as long as this maze right here is getting kept within 90 or 180 degrees, so like so, or like this, or any of these directions, as long as it is 90 or 180, it is going to work just fine, because we will set up the axe blocking depending on the rotation of this actor. So what I'm going to use for this video is a thing called physics handler, which is going to allow us to move our let's call those keys, and they will allow us to move these across our maze to find the correct location. Let's begin with working in our first person character. And in the previous video we created these things in the previous door puzzle video, and in today's video we shall add a new component to our character, and this needs to be the physics handle, and this basically allows us to walk around with a physics object. Now we don't need to configure anything in it. By default it is working just fine, so let's create a couple of events. So the first one, so custom event, is gonna be, let's call this start holding. This is going to initiate the holding event. So we need an input, which is going to be our holdable, which needs to be an actor. And then we need another input, which is going to be the hold component, which is going to be the primitive component, and that's going to be the actual thing that we are going to hold, the component, and not the whole actor. Now what we want to do is promote both of these to variables, so let's call this holdable, and the other one, let's call this hold component. There we go, both of these have been promoted, so we can now access these. Next thing what we want to do is drag in our physics handle, and we want to run a thing called grab component at location with rotation. So now let's connect this one up, and for the component we want to connect our hold component. There we go. And for the location we want to get the world location. We want to use that, and for the rotation we want to get the world rotation. There we go, so we plug those in. Now the next thing that I want to do is I want to have something that identifies us that we are actually holding something. So I will add a new variable, and I'm going to call this is holding, and then we are going to set this to be true once we have began our start holding event. And for now that's gonna be it for this function. Now let's create another custom event, because we need to have a loop on this one, because we're going to call this keep holding, and this function event is going to be looping, and it's going to constantly change the location of our holdable. For this one we don't need any inputs, but what we want to do is drag in our physics handle, and we want to set target location and rotation. Actually we only need the location, so set target location We don't need the rotation is gonna stay the way it is. And for the location, what we want to do is get our first person camera. We want to get world location of the camera, and we want to get the forward vector. There we go. Then we are going to multiply our forward vector times integer, and what I think would be a good value would be around 300 units. I don't think we need any more, so let's add both of these vectors together, and in the result we get the new location. The issue by default will be that our holdable is going to be moving around in the locations we don't want them to go to. Basically, we want to move our key up, left, and right only, so we will lock one of the axes depending on the rotation of our maze. So in here it is okay to pass along all of the values x, y, and z, since one of those is going to be blocked and it's basically going to be ignored. Then once we set the target location, we want to do a delay. So let's do a delay. Let's do this like a very small delay, perhaps 0.001. Seems to be good. Then I want to do a if branch check, because I want to check if we still are holding something. And then if we are still holding, then we want to run our keep holding, so on true, keep holding, so it's gonna loop this event all the time. And we shall do some more adjustments in a second. Now let's create one last event over here, so custom event, and let's call this drop holdable, and this is gonna allow us to drop what we are holding. And so here we again want to drag in our physics handle, and we want to release the component that we are holding, so we want to set it free, and we want to set its holding back to false. Now one more thing, since I want, once I move my key in a certain location, I want it to stay there, but we are only able to use the physics handle if we simulate physics. So once we shall start working with our holdable, we want to enable the physics, and once we finish working with it, we want to stop simulating the physics. So on drop holdable, once we are setting this is not holding, we want to select our hold component, and we want to set simulate physics, and we want to set it back to false so that our key would not fall down. Now that we have these events all set up, what we want to do next is over here on the false in our keep holding event, if we are not holding, then we want to run our drop holdable. And also in our start holding, at the end of it, we want to start running our keep holding event, like so. So this should look something like this. Now the next thing that I want to change in this first person character, here on keyboard keys E and Q, we are interacting with the puzzle in a certain rotation, and I want to keep on interacting with my keys with E and Q, but I want to do some things a little bit differently. So let's drag this back a little bit, let's hold control, and let's do an if branch check, and we want to check if we are holding something. If we are not holding anything, if this is false, then we can interact with our puzzle. But let's say we are interacting with the puzzle, it starts to hold something, and then we click it again, and we want it to stay there, so then we shall drop our holdable on the second click. There we go. One more thing that I want to add to this whole thing is on the keep holding, we are checking whether we are holding, and then on true or false we are doing what needs to be done. But there is another thing that I want to check for. So on true, if we are holding something, I want to do another if branch check, and what I want to check for is that we are not too far away from our holdable. So I'm going to drag in the holdable, and from this holdable I want to get distance 2, so get distance 2, and the other actor is going to be a reference to ourselves. So see, when we want to see what's the different distance between us and the thing that we are holding, and what I want to check for is that this value right here is bigger or equal to, let's say, perhaps 200 units. So let's do an if branch over here, let's check that, If this is true, that means that we want to stop holding and we're going to drop our holdable. Like so. If this is false, if the distance is smaller than 200, then we want to keep on holding what's in our hands. So that's basically going to be all that we want to do in our character, and everything should be good on this side of the things. Now let's create the actual maze. So in my content browser, I'm going to create a new blueprint class. I like to use the static mesh actor, so I'm going to use that one, but it doesn't really matter that much. Call this BP maze perhaps. Let's open this up. Let's see. So the static mesh component, I want to use my, how did I call this, puzzle cube. There we go, we have our puzzle cube. But the issue is, if it's a default one, yeah, we cannot rotate this. So I'm going to duplicate this and clear the parent. Select the second one and rotate this the way we want it to be. There we go. So this looks just fine. And one thing that we want to keep in mind of is that let's go and look for our assets. So here I have my puzzle cube. By default, it has the simple collision. And mine is not simple anymore, so let me go and change it back to default. So by default, you can see it basically creates a cube around it, and these spaces right here are not accessible. They are, the things are going to be colliding with them, and nothing's going to work the way it should. So what we can do is simply, as long as we don't need to enable physics on the maze, we can scroll down and look for collision and change the collision complexity from project default to use complex collision as simple, and now you can see that it generated a complex collision box with a possibility for us to walk through and throw things through these holes. So we are good with this, but also on our puzzle key asset, by default it also is going to have like a capsule around it. I've already changed some things up a little bit, but I'm going to show you what I did. So if you turn on the collisions, you will see probably a box or something around it. What you want to do is go to your collisions and you want to remove collision. And this is going to remove all the collisions that this object has. Then what I did was clicked on again collisions and I added a capsule collision. Then I can select this collision, make it a little smaller. The sizing probably is not going to be the way you want it to be. So with this collision box selected, scroll down till you see the collisions, and then we have these primitives, and then we have them in the groups, so spheres, boxes, and capsules. Let's select our capsule, and let's see. So we have a radius, so let's make the radius a little smaller. So it seems like 3.5 would be a good size. Then we want to change the length of this as well to make sure that it's a little bit hidden so that we cannot really see it that much. So let's make sure it's all good and done. We can adjust the locations as well with these values right here. So let me just simply change these to zeros. Scale this down a little more. There we go. So this is good. Now the next thing that I want to add is another collision, but this is going to be a box collision. And now what we can do is scale this down and move this into this top piece right here. And again, let's look for our box collisions. Let's change the Z extent. Let's make this a little bit smaller. Well, it jumps too high, so we have to adjust this manually a little bit without the snapping grid. There we go. So somewhere around here. And I believe this will be good enough. Then let's select this again and press Ctrl W. This is going to duplicate it. So now you can see in the boxes we have 2 entries. Let's select one of those and move it down. And actually let's press Ctrl Z to reset it because it's over here. So I will simply select this one, copy the 0. So right click, copy, paste it in the 1. Now both of them are at the same location. Now we can select one and now we can go down. There we go. So that's way better. Now let's see the collision box perhaps. So let's select the box number 1, and let's change the Z to somewhere around here. So this should be good. It doesn't need to be perfect. All we want to make sure of is that this thing is has some collision, the axis, basically middle axis, and so that these things right here would hold our key inside of the maze and that they wouldn't fall out of it, basically. As long as it's somewhat close to the actual mesh, it's all good and there is no problems with that. Now let's go back to our BP maze and let's see. The next thing that we want to probably add is our keys. So let's add a new static mesh. There we go. We don't want it to, we want it in the same hierarchy, same level. We don't want it to be a child, so make sure they are both in the same rows. Since I have this one clicked, that's the reason why it selected selected the key by itself automatically. So you can see it, I have it here already. So let's move it in its location. Let's say this would be good enough. And what I will do is rename this to be key 1. Let's duplicate this. It's going to be instantly key 2. Let's move it over here. Duplicate this once more. Key number 3. Move this to the other side. And now what we need is the checkpoints to which basically the destinations of our keys. So for that I will add a box collision. You can use any collision box. Let's scale this down. There we go. And so my locations are going to be over here, so this is going to be one of them. Let's duplicate this. Then we shall have another one over here. Let's duplicate that one once more, and let's move it to the other side, and this is going to be my third one. They don't absolutely have to be just perfect, as long as you think if the axis is going to hit it, then it should be good. So I believe mine should be good. If you want to be precise, you can actually size it up a little bit, but that's not that important, I believe. Now, the next thing that we want to do is, from the previous video, we want to add our interface. So let's go to the class settings and let's add an interface. And we had our, let's see, interact with puzzles interface. If you haven't watched the previous video, so let me show you the interface. Here's the interface. It's very simple. All it has is just one function with a couple of inputs: primitive component, rotate left, and the player. For this exact maze, we don't need the rotate left, but we have it for the previous puzzle that we had in the previous video. Now, once this is all done, what we want to do is add another variable to this, and let's call this door. And we want to select our door actors. So BP door actor, there we go. We want to make it instance editable and exposed on spawn, just like in the previous video. Now let's go to the event graph. Let's see, let's delete these two. Let's right click and let's create ourselves an event interact with the puzzle. There we go, our interface event. And here we want to do a if branch check. And what we want to check for is that we are interacting with the correct component. So from the component input, let's do an equals. Let's copy this 2 more times because we have 3 keys and we want to make sure that we are interacting with one of those keys. So let's drag in our keys. So get key 1, get key 2, and get key number 3. Let's make sure we connect all of our keys to over here. So key 2 and the key number 3. And then we want to connect also our component, like so. Then from this Boolean value, we can do an OR check, or Boolean, add another pin, connect all of these, and this basically checks if we are interacting with one of these keys. Then we can do an if branch check to make sure we do. And if we are successful, if this is true, then from the component, we want to simulate our physics, so that our physics handle would be able to interact with this. Then we can simulate the physics, set this to true, and from the player, then we can start holding our component, connect it like so. The holdable is a reference to self, and the hold component is the component from the input, like so. Now, the next thing what I want to do is, like I mentioned in the beginning of the video, we need to block one of the axes. Otherwise, I couldn't find a way how to make this work. But if we block one of the axes and have like a full 90-degree rotation in any of the directions, everything is working just fine as long as the rotation is 90 or 180 degrees. So over here on begin play, let's drag in our, let's get the actor rotation. There we go, actor's rotation. Let's split this value because we need the Z value. And what we want to do is from the Z, we want to check if this is nearly equal float. There we go. Let's give this some error tolerance. Let's say 5. It's too big. I think 1 should be good enough, but just for the safety purposes, perhaps give this a 2 or 3 or 5. And then we will want to do an if branch check, but not just yet, because first we need to put in the value. So this is going to be 0. Let's copy this once more and let's type in 180. And then let's connect the A again. Let's copy these nodes, 2 more nodes. So 2 of these, copy, connect the A to the Z, and here we want to type in -90, and the other one is simply 90. Then we want to do an OR Boolean check over here to check if it's one of these two or one of these two. There we go, like so. Then we want to do an if branch check to make sure, to ask whether if it's these two. If it's not, if it's false, then we can do another if branch check to check if it's maybe these rotations right here. Then let's work on the true from the top. If it's one of these rotations, we want to get all of our keys. So hold Control, select all of them, drag them in. And here we want to set the constraint mode, like so. On the true, we set the constraint mode. And on this example, on 0 and on 180, we want this to be XZ plane. So this allows us movement in only the Y and Z axis. Now let's copy this node 2 more times because we have 3 keys. So let's make sure we connect all of our keys like so. And let's make sure we connect the execution. I'm going to go upwards. Now I'm going to copy all of these and I'm going to copy these down here on the true. Also, I'm going to go upwards. But for these ones, I'm going to change the constraint mode from YZ to XZ. Like so, XZ, XZ, there we go. So now we're going to be locking in just fine. And the last thing that we need is to actually check when we can open the actual doors. So let's create a new function and let's call this check code. For this one, let's see, we need a couple of inputs. So the first input probably is going to be our component, which is the primitive component. Then let's add another variable. Let's call this index, because this is going to be the index in our array. And then the last one, let's call this overlap. And this is going to be a Boolean. So this is basically going to determine whether we are putting the key in its correct location or taking it away from that correct location. So now, once we have all of this set up, we again want to drag in our keys. So let's select these, drag them in. So we have our keys, and what we want to check for is which one of these, whether one of these is equal to the component that we are providing. There we go. So this one component and the key. Then we want to do a OR Boolean check. There we go, OR Boolean check. Then we can do a if branch check. And now we need the actual array. So let's create again a new variable, and let's call this code is good. I believe we called it in the previous video. Let's make this into a Boolean and into an array of Booleans. And since we have 3 keys, we want 3 entries over here. All of them need to be false by default so that the doors would be closed. Now we can drag our code is good, get it, and from this one we can set array element, connect this to true, connect the index to the index, and overlap to the item, excuse me. So once we have done this, the next thing that we want to do is, if you watch the previous video, we can just simply go to our BP puzzle and we can go to our check code and we can copy the end part from right over here. So that's exactly what I'm gonna do, but I'm gonna explain it as well. So let me just copy this inside of here. So what we have over here is we are looping through our code is good. Alright, right here we are checking the values whether they are true or false. If they are false, then we are creating a local variable. So I'm gonna right click and I'm gonna create a local variable, and that's the one over here. So you can create a local variable right here, and if this is false, then we are setting local failed to be true, and then we can go to the break of the loop. And once the loop is completed, then we are checking whether we have failed. If we have failed, then from our door we are closing the door. If it's false, that means it's all good. That means we can open up the door. In case if you haven't watched the previous video, let me open up. This is our BP door. It is a regular door actor, and inside of here we have our open close door events, which are run through the timeline and just simply changes the rotation, and they have the default rotation set at the begin play, and so we combine some of the degrees for the rotation with the default rotation so that we can basically place them wherever we want. And that's basically all that we have here, 0 till 90 in 2 seconds, and yeah, that's as simple as it gets. Now that we have set all of this up in our BP maze, I believe we are pretty much done. So the last thing left for us to do is go back to the event graph. Let's select our box collisions, or whatever collisions we have, and let's run our on begin overlap and on end overlap events. And we want to do the same thing for all of our collision boxes. So let's do so. There we go. We have 6 event nodes right here, which is quite a lot, but since we have 3 locations, we want to have 6 nodes over here. Over here, what we want to do is on the first one, let's drag in our check code function, like so. The component is going to be the other component. The index, in this case, is going to be 0, since this is the box 0, so the index is going to be 0. And the overlap is going to be true, since we are beginning to overlap. Now let's copy this, connect it like so with the end overlap box 0, use the other component as the component index 0, and this now needs to be false. Now I'm going to copy both of these to over here. Again, connect these like so. Again, connect the other components. So this is box 1, so the index is 1, and this index is 1 as well. And so this is the overlap, this is not overlapping. Then let's copy this once more for the last time. Connect the execution pins, connect the other components. Other components, and this index is index number 2 and index number 2. There we go. So as of right now, everything should be working just fine, but I want to do some debugging. So let's see, on begin play, I want to show you that the rotations are going to be working just properly. So let me just print string, and what I want to print is simply the z-axis value at the beginning of the play. So that's all that I'm going to do. So let's minimize this. Now let's bring in our BP maze. Let's move this up a little bit. Now let's drag in a door actor over here, and now we need to connect our maze with the doors. So since we exposed our door variable, we can check this pick actor from scene, and we can select our door. So now you can see BP door 3 has been selected. So now let's try to test this out. Let's press play. Whoops, don't shoot. Let's see, let's press E on this one, and you can see once we press E, it is it's starting to move around. Let's perhaps walk away from it, and this should now detach from us. So now we can press E again. There we go. Let's move this up. Let's move this into its location. Press E, and it stays in its location. Now let's try this with the second one. Let's see. Let's move this up. There we go. The doors are still closed. Let's select the last one. Let's move this up a little bit. And once we move this in the location, the doors get opened. So now we can select this once more, move it down, and you can see the doors are getting closed. Now in the console, you can see the degrees are 0 by default, and everything seems to be working just fine. Now I've selected the actor, And pay attention to rotation axis Z. Now let's say we rotate this 1300 whatever degrees. As long as it has, like I said, 90-degree or 180-degree rotation, it should work just fine. So now if we press play, you can see it displays that it is 89.9999 degrees. So it's going to be working just fine. So we can walk up to this, press E, and play with our keys and put them in the correct location. So I move. There we go. So key number 1. Key number 2. Well, I went the wrong route, but you get the point. It is working just fine as long as it does meet those requirements. So now let's press play. You can see it says 0. Let's rotate this 90 more. Now it says minus 90. Let's rotate 90 more. Now it says 180. And once we keep on moving, it's gonna now say only 90. There we go. So basically this z-axis value doesn't really matter because it never goes more than minus 179 and it goes up to 180. So that's gonna be it for this video. Like I mentioned, this was requested by one of my Patreons, so if you want tutorials created specially for you, make sure to subscribe to my Patreon, join my Discord, subscribe to my YouTube channel, and I see you guys in the next video.